So what is a radian? Well, let's say that we have a circle like this with radius r. Let's say this is the x-axis and this is the y-axis. And if we draw a line like this with respect to the x-axis, it makes some angle theta like this. Measured from here, we say that theta is so many degrees in this direction. Well, the idea of using degrees to measure the angle is somewhat arbitrary because we've chosen 360 degrees to be a full circle. But another way to do that would be to look at how far along the circumference we've gone. Let's call this distance here S. And if we move along the circumference up to about right here, we've traveled a distance r along the circumference. When this distance S is equal to r, then this angle right here is 1 radian. Let's call this S1 and let's call this theta 1, where that represents 1 radian. So the question is, how many of these radians can we fit into a circle? How many of these pie-shaped slices here can we fit into a circle? We can figure that out easily by writing that the circumference is equal to 2 pi r. And if we divide the circumference by S1, how many times will S1 go into the circumference? And that's 2 pi r divided by, well, when S1 is equal to r, then that's equal to 2 pi. So 2 pi radians equals 360 degrees. That's a nice conversion factor for you. And the fact that we're measuring theta as the ratio of S over R, we also have that S is equal to R times theta. Also notice that our conversion factor up here can be written as pi radians. Pi radians is equal to 180 degrees. And that one's the one that's a little more convenient. And let's say we want to know, for example, how many degrees are in 1 radian. So 1 radian, we want to know how many degrees are in it. So that means that pi radians is 180 degrees, like this. And so that's equal to 180 divided by pi degrees. And that works out to be, and let's put it in here and see, 180 divided by pi equals 57.295, approximately 57.3 degrees is 1 radian.